Hello grade 9 learners, welcome to this video. In this video, I will introduce to you a property that you can make use in solving quadratic equation. By the way, when we say you solve a quadratic equation, that means you are to find its roots or solutions. And when we say solutions or roots, these are the values of the variable that will satisfy the given quadratic equation or will make the given quadratic equation true. The square root property states that if x squared equals k, then x is equal to positive negative square root of k, where k is a non-zero real number. Observe that in this statement, the given equation x squared equals k is quadratic. Now, to illustrate how is the square root property applied, let's start with this first equation. So here we have x squared equals 4. Here, our value of k is 4. So if we will apply the square root property, x will be equal to positive negative square root of 4. And the square root of 4 is 2. Therefore, the values of x will be positive negative 2. And these are our roots or solutions. You may check it by substituting positive 2 or negative 2 in x here. So if x is positive 2, square it, the answer is 4. And if x is negative 2, even it's negative, if you square it, the answer is still 4. So, our roots or solutions are positive 2 or negative 2. Now, let's have another example. Suppose we have here x squared is equal to 25. So, in this equation, our k is 25. So, if we will apply the square root property, so x will be equal to positive negative square root of 25. And what is the square root of 25? The square root of 25 is 5. Therefore, the values of x will be positive negative 5. And these are our roots or solutions of this quadratic equation x squared equals 25. How about if we have this example? Suppose we have here x squared is equal to 20. In this equation, our k is 20. Observe that 20 is not a perfect square compared to 4 and 25 because 20 doesn't have an exact square root, or 20 or the square root of 20 is not a whole number. So 20 is a non-perfect square. So if we will apply the square root property, we will have x is equal to positive negative square root of 20. So since 20 is not a perfect square, so we cannot get the exact square root. So what are we going to do? If our k is non-perfect square, we can simplify it. So how are we going to simplify it? So this is what you're going to do. From your given 20 or square root of 20, you will factor it out in such a way that one of the factors is a perfect square. And what is a factor of 20 which is a perfect square? That is 4. Because 4 is a perfect square. And if it is square root of 4, this would be square root of 5. Because square root of 4 times square root of 5 is square root of 20. Now, getting the square root of 4 to, this is non-perfect, so we just copy this. So, square root of 5. So, this is now the simplified form of square root of 20. So, this is read as 2 square root of 5 or 2 times the square root of 5. So, therefore, your roots can be positive, negative, 2 square root of 5 as simplified form. Now, how about if we have this example? Suppose we have x squared is equal to 15. Now here, our value of k is 15. So if we will apply the square root property, we will have x is equal to square root or positive negative square root of 15. Now observe that just like 20, 15 is also a non-perfect square. But as you will observe, 15 has no factor, which is a perfect square. What are the possible factors of 15? We have 5 and 3. And 5 is not a perfect square, and so with 3. So therefore, this will be our final roots or solutions. And we cannot simplify anymore square root of 15. So in other words, if our k is a non-perfect square, we can simplify it. But we can only simplify it if your k or your number, your radicand, the number inside the square root sign, has a factor which is a perfect square. Otherwise, you cannot simplify it. Now, observe with these 4 examples here. 4 is a perfect square. 25 is a perfect square. So we have extracted their square roots. So these are rational numbers. So if we will describe the roots of these equations here, the roots are rational numbers. While on number 3 and number 4, square root of 20 and square root of 15 are irrational numbers. They are non-perfect squares. But still, they are real numbers. Now, let us consider this example. Suppose we have here x squared is equal to negative 9. What do you observe? Our k is negative. So if our k is negative, what will happen? So here, if we will apply the square root property, so x will be equal to positive negative square root of negative 9. But the question is, can we get the square root of negative 9? The answer is no. Why? Because by definition of square root, there is no number when you square, the result is negative. So remember, any negative number doesn't have a square root. So they don't have square roots. So actually, they are not real numbers. So if your k is negative, you cannot get the square roots, and they are considered not real numbers. How about if our k is 0? Suppose we have here x squared is equal to 0. Observe that in our statement, k is a non-zero real number. Why? What will happen if k is 0? Are we going to have the values of x positive, negative, square root of 0? No. Why? 0 is neither positive nor negative. That is why if k is 0, the only solution for x is just 0. We don't have positive, negative square root of 0 or positive, negative 0. Because 0, again, is neither positive nor negative. Now, if you're going to observe with these examples that I have illustrated to you, as far as our quadratic equation is in the form x squared equals k, we'll have the following generalizations. 1. If k is positive or greater than 0, like 4, 25, 20, 15, our equation has two real roots. Maybe the roots are rational numbers or irrational numbers, but still has two real numbers or has two real roots. And if our k is negative or less than 0, our equation has no real roots. And lastly, if k is 0, our equation has only one solution.